من قبل بترا سمع فرق
እግዚአብሔር ለምን ደሪ እስክሪንሾት ታሪክ ለማግኘት
and also resource constraints problems like limited bandwidth, computational power, battery lifetime, and storage capacity of the devices are very challenge issue in vehicular for computing devices. So many different studies are propose many solutions for these challenges. However, the newer vehicles are optimizing quality of service requirements remains the challenge. To explore recent work and perform meta-analysis of task offloading methods in vehicular for computing, and also to optimize quality of service. Even these are the main challenges that remain in the gap of the articles that's previously done. So in our methodology, we collect another we exclude based on the abstract and the titles. That means we prepare abstract and the titles. That means we prepare the key for the selection for the selection that relates to the topic, that is for competing network, for competing vehicles, and also task offloading, and also resource provisioning is the key that we search the articles. Finally, 80 papers was that related with the topic was analyzed and discussed in this paper. So we prepare some research question that guides this systematic literature review to become in the goal that proposed in previous. This is the research questions that we prepare. So we discuss existing system, that means 18 papers that is related with the topic. We analyzed the gap of all 18 papers in depending on the quality of services that we arrived in previous, depending the focus area that we select, that we analyze. Those articles are, example, resource pooling in vehicular for computing, resource allocation, how the resource was allocated in vehicular for computing, and also task scheduling and the approaches. There are many different approaches are available, but from comparing different the vehicles, the communication is very complex at that time. And the final challenge and the research gap is what? Quality of service. That's we didn't get the quality of service in previous workers. Quality of service in previous workers. So our contribution is what? In-depth analysis of vehicular for computing architecture and approaches for quality of a service enhancement. For quality of a service enhancement was discussed and compared in detail. Evaluation of previous infrastructure dependencies in vehicular for computing networks, highlighting and the limitation. Insight into resource limitation, the challenge in achieving quality of service, critical comparison analysis of task offloading model, and approaches were discussed in detail. Our recommendation for the future workers, prediction-based task offloading system is very recommendable because the vehicles are what? Non-stationary. So accepting resource availability to optimize offloading decision. Dynamic resource allocation is also another recommendation to adjust resource in real time to meet varying demands efficiently. Real-time decision-making remains crucial for critical applications. So thank you very much. If you have any question or if you have any idea on this research area, you can ask me. I can recommend you even titles also.
Thank you, Doris. Any questions? Something new, right? It's fascinating how technology progresses. We have cars in the city. They act dumb because they don't communicate with each other, right? But the world is moving in that area where even now cars have to talk to each other. And one of the design requirements of 5G and the next generation 6G is to enable vehicular communications. Now, what he's doing, working on is one step higher, because now we're talking about computation, right, happening on the cars. And when some car requires some computation, it's not doing it. If it cannot do it, it's idea is okay, let me give it to the next car, right? And that car can do the computation. That problem is significant, right? So I have one question for you, actually. So this question is what is the one problem, right, that is significant? If solved, can solve most problems in this particular case.
Okay, thank you. Depending on his question, maybe I will explain about vehicular for computing and then so how I came to this research title that is maybe important for you also, for students who are here. When I start here my PhD, actually my PhD was registered here. I'm admitted at Adama University. However, I get a chance to go Germany while discussing with Professor Hakem, who's my advisor, my second advisor. My main advisor was in Australia. Then I present this title. Then the title was very famous in another world, not like Ethiopia, developing country, but underdeveloping country. But in another country, they are doing their own self-driving cars. So actually, and after I moved to Germany, I get another chance to work with Volkswagen. If you know, I don't know. Volkswagen, yeah. They are very motivated to my title research, and they asking me as I do there. I don't know at what time I start with them, but I'm in progress. So technology is the way we are thinking, and the way the technology is here are we are in different gap. We are in different phases. So actually, when I start like another title, but my main advisor advised me to do on IoT, Internet of Things. First, I draft my proposal in Internet of Things in Vehicular for computing. Then I moved I little bit modify my title to from Internet of Things to resource allocation and the task offloading. That is a big issue in the world, because first we use what? Cloud. One vehicle to execute his duty, it sends to cloud. It takes a long time to execute and return back to the vehicle. But however, now today, the vehicles are communicating to each other. If one vehicle have no capacity to execute his task, he can share with a neighbor vehicle, and that vehicle, depending on the quality of service, it executes and return back to the initiated vehicles of the tasks. This is the idea. It may be new for you, I don't know. You can get a lot of papers a lot of researches are done in this. you can get pointers, and also maybe you got my name, you can got a LinkedIn. If you are interested, you can contact me to do on this research. Thank you.
Thank you, Doresa. Your work is very interesting. So basically what you're saying, like, if we can solve the resource sharing between the cars, that's a problem solved. Yeah. Any questions before I close? Yes. Yeah. When we're done with this, there is tea. We can go for that and come back again to see if the other speakers are back. Okay? Yeah. So wait. Answer his question.
Okay, thank you, Doresa. One of the challenge in VANET or Vehicular Radio Network is that the communication, which is vehicle-to-vehicle communication, easier, and vehicle-to-infrastructure as well as onboard unit easier. So in vehicle-to-vehicle communication, there are some forgery nodes are there. That means there is a forgery node that will distribute a false information. That means either have you accessed, we user survey those challenges. That means while we conserve a resource, also having this one in mind is also, consider this thing is also one of the challenges nowadays. So have you accessed, we user survey, any that is forgery node detections, or there is a node that will distribute a false information in between the vehicle-to-vehicle communication? Thank you.
Okay. Thank you. As I raised, the main problem in vehicular for computing is what? The dynamics of the nature of the vehicle. Because the vehicles are not stand on one station, they're always moving. There is infrastructure that, like my brother raised, roadside units infrastructure are there. Previously, they sent their tasks to infrastructure, then infrastructure find which vehicles have a resource efficiency to give what? To give the task for the free vehicles. But nowadays, they are removing our roadside unit infrastructure. Because of what? Because of the quality of service. Because of the delay time. So they are doing what? They are communicating directly to vehicle. They have execution power, they have execution memory, they have execution of, depending on the tasks that one vehicle initiates the tasks, they depend on that tasks. It may be a quality, it may be the memory, why the previous task will be, the previous vehicle will be not executed. Then depending on those quality of service, they execute and they immediately send for the nearby vehicles. So previously, I think as I see, I see many researchers doing on what? The infrastructure on the roadside units. But nowadays, they are changing to communication between each other. However, still there is a challenge. Because of what? Because of the nature of the vehicles. So if task will be executed or transmitted for another vehicle, the vehicle will be maybe in 1 microsecond or after 10 microseconds, that vehicle will be gone. Then without execution, without getting the result, that executed task will be returned back to the initiated vehicle. However, still the researchers are motivated on doing this issue and the challenges, but I don't see to give you a real result. I don't see any research that is directly proposed the real proposition solution. However, as I told you from different articles, my contribution, the recommendation was prediction model for dynamic task offloading is preferable. Thank you.
Thank you, Doresa. Give it up for him. So let's meet after 20 minutes. at 3:50. Okay? Thank you, everyone. Hello. እንኳን ደህና መጣችሁ። Hello. እንኳን ደህና መጣችሁ። So ቅድም በመሃል ሁለት የቀሩት ሰዎች አቅራቢዎች they have sent us their recordings of their work. So we will play the work by Sleshi Nibrat Zelleka. His work is on integrating explainable AI for the effective malware detection in encryption network. No, not encrypted network traffic. And he will later on will be here online. So if you have any questions, we can direct it to him. So play the video. Thank you.
Is Sleshi Nibrat. I'm presenting you our study on integrating explainable AI for effective malware detection in encrypted network traffic. This study was done by me, Sleshi Nibrat, I'm Saluk Antejambar and Mario Oberkikyo from the University of Bari Aldomoro. So basically, in this presentation, I will present you about these 5 points, 5 main points. Of course, as usual, we do the introduction and then we continue to the methodology, and then we study. We present the result and discussion and the explanation techniques and explainability aspects of our study. And finally, we will conclude our presentation with conclusion points and also future work directions. So, as we know, malware is the big aspect of cybersecurity on the cyberspace. So, malwares present a significant threat to the communications. So, these days, every network and every traffic all over the internet are more or less encrypted, but malwares are also now using the encryption techniques. In fact, these encryption techniques help the malwares to have a better attack or a better space for their malicious activity. For that aspect, artificial intelligence could be a potential solution for for detection without the need for previous signatures or fingerprints. In addition to that, explainability could also enhance the detection techniques or the detection ability of models and help the cyber analysts for their advantage. Basically, what we need in encrypted network, we need a deep analysis of encrypted traffic or robust data sets. For that case, we may use interpretable AI techniques for effective malware detections. Given that, the challenge of AI-based detection systems are advantages and there are also disadvantages of these AI-based systems. The first one is detecting malicious traffic without decryption allows privacy preservation. In fact, we do have to decrypt or we do have to see what's inside the data. So this helps for privacy preservation. The other one is reduce the processing overhead between on the end devices. I mean, or on the intermediate devices, on firewalls and such devices. And the other advantage is to enable organizations to implement the detection mechanisms that can function seamlessly without having to deal with every traffic or every communication aspects. Given this, there are also difficulties on AI-based detection. The first one is to identifying the malicious traffic without decryption can sometimes lead to false positive aspects. So this in fact leads to false alarm. So the other disadvantage could be the limited visibility into traffic contents may lead to a higher chance of detection and things like that. So this study has objective of three basic things. The first one is investigating the explainability of AI models for this encrypted malware detection. The other objective was to introduce a dataset which contains 1,127 unique connections from 54 different malware families. The other one is to provide insight on the important features influencing model detection. So basically, to study these aspects, we follow this methodology. So the methodology we are following is first we have raw network traffic, which is encrypted network traffic, and then we construct a flow which is a factorial, meaning that we have the server and the clients, and then the communication between these two entities is extracted as a flow. So when extracting a flow, we are just focusing on the tailless communications, meaning that only encrypted networks are important for our analysis. And then we construct factorial flows from these communications, and then feature extraction was done on this part of the method. Given this, we continue to pre-process the data. So basically, in the pre-process, what we done was normalizing features and then do one hot encoding for categorical features. Given that, after observing this, we continue on model training and validation, and then we continue on testing and explanation for the proposed models. So the data preparation module contains this flowchart, meaning that we have the raw traffics, and after we have the raw traffic, we just focus on the 30 minutes of the communication window for our models, since in these 30 minutes more than enough damage happened in malicious communication. So we focus on this 30 minutes communication behavior. Then we construct if it's larger than 30 minutes, we only need 30 minutes of the communication. And then we filter the tailless packets from non-encrypted packets, if there is non-encrypted packets in. And then also the communication should complete the handshake procedure. So if it does not complete the handshake, it will be discarded immediately. And based on that, we construct a factor bidirectional flows. And then we have the feature extracted the JSON file. Then from that features, we continue to pre-process. So for that, we use a Wireshark tool, mostly Python script for our analysis. So basically, features could be categorized into 3 points. So basically, what we do was extract multi-view. So when we say multi-view, we are saying that we extract features from a client point of view and from a server point of view. So meaning that we take also the client behavior and also the server behavior on the malicious communications, and we utilize the handshake details, also the time between the communication time between the client and the server, in fact, was taken as a feature component. So for our study, we use two datasets. The first one is the one we construct as we described before, is in the methodology described before. And the other one is the CTU13 dataset, which is composed of botnet and normal traffic. And this dataset is used as a baseline for our analysis. So to compare our dataset with the previously introduced datasets, most of them have limited small number of malwares, but we include 10 malware types. These 10 malware types are contains around 7,000 malicious flows, clear malicious flows, and these 7,000 malicious flows are from 4 different malware families. So we have a large number of malware families represented in our communication. So we also consider a unique communication of IPs. We don't use redundant IPs or redundant communications, since every malware servers and clients communicate with a certain client in a different way. We use unique IP addresses. So the dataset is comparatively composed of robust samples. So when we test our systems, basically what we did was employ ensemble tree-based models such as random forest, XGBoost, and extreme randomized tree. So for that, we test our datasets on 3 of the datasets. The other dataset we introduced was imbalancing the dataset. So imbalanced dataset is based on our dataset, but it's more realistic than balanced dataset, since malware samples or malware attacks happen probably 1% or 2% of the communication, as previously studied from the other studies. So we imbalance or we oversample our normal traffic for balancing, and then we tested these 3 aspects, and in all the experiments we see that extreme gradient boosting algorithms outperforms the other 2 ensemble learning methods. Specifically for our balanced dataset, it achieves an accuracy or F1 score or every matrix above 99% as the detection performance. So the other thing we follow was the global and local explanations. So for global explanations and local explanations, we employ Shapley values. So of course, global explanations are important for overall behavior of our detection models. And for that, we use we test on all datasets of our experiments. Also, for local explanations, which are specific for a specific for individual samples, we test on our dataset on also at the same time on the CTU 13 dataset. So both local and global explanations contribute to the transparency and the replicability of these AI-based detection models. So what we found on the global explanation was the flow time, the communication between the client and the server, and are more effective features or more affecting features for the communications. So these features affect, for example, the the forwarded packets from or forward bytes from the servers to the clients. The size of these packets are really determinant of the malicious communication on our dataset. Also, the packet lengths, the minimum packet lengths between the malwares and the normal traffic is also a determinant factor. In fact, it's a high determinant factor of the detection. Also, the finish flag count between on the handshakes also shows a significant contribution to the detection. Moreover, on the CTU 13 dataset, we see that the maximum packet size and the maximum, the mean forwarded byte are effective features for the detection of the malwares and the normals. So the key features for detection includes maximum packet size, mean value of inter-arrival time. These are the most effective, the most determinant features in the communication or in encrypted communication. So sharp values provide insight into the model decision making, which in fact enhance the model explanation, or I mean the model detection. Also, on the local explanation, we see that different features have different effect on separate samples. So, given that on this study, we see that the normal traffic have different pattern than the malware traffic. Moreover, the normal traffic consists of consistent and balanced data transmission between the clients. So the clients and the servers send mostly consistently on every time interval of the communication. So the statistical features like bytes sent, received, and from the client to the server remains within the expected range. The statistical features remain mostly on expected range, but in malware traffic there is irregular data transmission, meaning that sometimes there is a large number of packets transmitted from the client to the server and vice versa. So irregularity between the data transmission at a given time have been discovered on this study. So normal data transmission behaviors such as sudden spike of packet size, unusual timing pattern are more characteristics of malware traffic. So we compare our study with the existing study. There is a novel proposed a novel approach on explainability for encrypted traffic detection. As far as we know, we couldn't find a study that specifically focused on explainable aspect of encrypted malicious traffics. Moreover, this study also performs better on the baseline studies relating to the computational performance or the based on the performance metrics like accuracy, F1 score, and precision. But the main objective of this study was not to enhance the accuracy into 90 point something%, but also to explore the explainability of the models, and that we achieved in a good point. So as a conclusion, of course, the absence of public accepted public dataset or more representative dataset is make an opportunity and also a challenge for our study. So based on that, we prepare a robust dataset containing 54 malicious or malicious families, which is a significant number of samples in one dataset compared to other previous studies. Also, this study we propose explain techniques for efficient analysis and for effective cryptanalysis or cybersecurity applications. We only focus on the encrypted communications, which is based on the transport layer security. We analyze without detecting, without decrypting the payloads. So different aspects like handshake communication metadata and the packet time and length have a significant contribution to the detection. Its own, first we need to have a more deep. First, we need to have more deep analysis on different samples, even more than more malware families, even more than more malware families could be used for more comprehensive dataset, and then probably the integration of these detection systems could safeguard the cyberspace. Thank you for your attention. If you have any question, I hope I will be available to answer. Hope I will be available to answer.
Thank you, Slashi, for the video.
So basically, we try to take all representative features, which are not just metadata, but from the Shapley values, we see that metadata have more determination on the differentiation between the malware and the normal samples. So the main idea is to not decrypt the traffics, so that we can detect the malwares even though it is encrypted. So features could be from different perspectives. Like I said, from communication time, the links, the metadata, also the handshake, the certificates that they share for communication, for encrypted communications, and things like that. So that's all features that we have employed. I hope it answers the question. So the other question that you have asked me was why Shapley values. So in fact, we employ Shapley values due to the fact that on our previous study we found that ensemble tree techniques are more efficient on our dataset and also on this aspect. So while we are doing our studies, we come across to the point that Shapley values are more efficient on tree-based algorithms. So tree-based algorithms or ensemble learning methods are more compatible with the Shapley values. Of course, they are expensive in terms of computations, but on this point of view, that it was more efficient in terms of the explainability aspect. I hope it answers all the questions.
Thank you for the explanations. Any other question? Any other question? Okay. The audience is refusing to ask you questions. I'm going to ask you one more, and this a question like coming from the first one.
Okay.
So like all of the features that you mentioned can also be used for non-encrypted data as well, right? So the question I was asking you earlier was like, why, like in your title, you said encrypted network, right? Because it could also be used for non-encrypted.
Okay. Yes. Some features could be for encrypted or unencrypted. But the main idea was we focus on the encrypted part because we also use like certificate informations like handshakes, how many time between the handshakes it takes, what cipher suites does the server selects, what cipher suites the client propose. These are all included in the 304 features that I said earlier. So basically, we focus on the encrypted part. Of course, there will be features that are common for also for unencrypted. But since I know why it's more conflicting, because on the Shapley values we see the metadata as more determinant, because we select only the 10 most important features from the explanation. But in general, the encrypted specific features specifically for encrypted traffics are also determinants of the communication. That could be the possible explanation for the outcome.
Okay. Okay, I like that answer. Any questions? Okay, here.
All right. I am asking this question because Dr. Fizum insisted on the audience participating. So my question is, how is explainable AI different from feature importance for your problem? Because you could have simply used vanilla feature importance analysis instead of Shapley values or other explanation frameworks.
Okay, thank you for the question. In fact, feature importance is we can consider it as technically we can consider it as explanation. So explanations in a sense that specifically for this aspect is just identifying which communication pattern or which communication property is more determinant of whether the traffic is normal or malicious. So on a technical point of view, they are the same. I mean, they identify the important property of the communication. Either we use feature importance or Shapley values. Yes, we can implement feature importance as explanations. So basically, what explanation do is the model arrives to a specific decision because of some feature variations of the normal traffic and the malicious traffic. So does feature importance do that? But feature importance sometimes are like it takes the more of the voting technique, meaning that how much or in how many instances that this feature have higher values or things like that. But on the Shapley values, it's more focused on the model detection, the model's ability to detect on specific features, not considering the other feature as well. So yes, Shapley values are more efficient in terms of tree-based algorithms, in fact.
Thank you, Saleshi, for the explanations and for the presentation. And good luck with your work.
Thank you.
Yeah. Okay, thank you. For the next one, are we ready?
name is Murar Tadesse, and I'm honored to present my research on the title Multimodal Attention-Based Fusion Authentication System with integrated liveness detection for enhanced cybersecurity here at the PanAfricon AI.
Pause it. Thank you. uh, Okay, the next topic that we're going to talk about is multimodal attention-based fusion authentication system with integrated liveness detection for enhanced cybersecurity. And this will be presented by Murat Tadessa. And the video would, we will look at the video, and I hope he will be online and we will ask him questions.
Hello everyone, my name is Murar Tadesse, and I'm honored to present my research on the title Multimodal Attention-Based Fusion Authentication System with integrated liveness detection for enhanced cybersecurity here at the PanAfricon AI 2024 conference. Thank you for this opportunity. Before we dive into the details, here is a quick overview of what this presentation will cover. First, I will introduce the core concepts and motivations behind this research. Next, we will explore some related previous works by other researchers. And next, we will see the methodology detailing how the multimodal fusion system is constructed. And then I will explain the experimental setup used to evaluate the system's performance. After that, we will discuss the results and their significance, and then finally I will conclude with some key takeaways and outline the future directions for this research. Let me start by introducing the key concepts, just by starting the introduction of this presentation. With the rise of advanced cyber threats, multimodal biometric systems have gained significant attention for their enhanced security. So there is a huge growing interest in multimodal biometric authentication due to they have higher security and robustness compared to unimodal and traditional systems like that of only using fingerprints or facial or iris or voice authentication systems, or even those common, even though they are not biometric systems like that of the passwords, pins, and patterns. Those multimodal biometric systems has more robustness and just higher security. And there is, in this paper, there's a proposed system, which is the novel multimodal attention-based fusion authentication system. There are three modalities in this proposed system. The first one is the fingerprint, and then the iris, and then the voice to improve security and robustness. In this presentation, I will walk you through a novel system I developed, which uses an attention-based fusion approach to dynamically weighs the importance of each modality and improve the authentication process. Additionally, I have integrated a framework for liveness detection to prevent spoofing attacks, even though it is not implemented due to lack of data set. The key contributions in this paper, my research makes several important contributions. First, I designed a multimodal attention-based fusion authentication system. And second, I developed attention mechanism for dynamic modality weighting. And then I comprehensively evaluate the system on diverse data sets for the three modalities. And then it achieves a 95.3% authentication accuracy, which is 1.3 improvement over existing systems. Lastly, I introduced a conceptual framework for integrating liveness detection into the system to add additional layer of security on the system. Regarding the liveness detection, as you can see from this image, which is taken from erratic fingerprint scanners, when it comes to the first fingerprint, this is live finger and it is just authorized with the correct fingerprint, but there are lots of spoofing or fake fingerprints, which is made up of different materials like gelatin, silicon, latex, paper, or just printed fingerprint. And there is wood, glue, and there is made from clays. And they use those fake fingerprints and try to be the exact individual, and they can attack easily if there is not liveness detection. So this concept is currently an emerging area of research, actually. When it comes to the challenges in biometric authentication system, the fusion of multiple biometric modalities it has its own challenge, even though the robustness and security is high. The adapting weight of modalities and the liveness detection integration is hard. It adds its own complexity on the system, balancing security and usability. When we come to the real-world implementation, it becomes a challenge. When it comes to related works, there are lots of previous researchers who come up with different ideas. For example, Last Sample, Rose and Jane, and their allies provide a comprehensive overview of multimodal systems. They come up with lots of labels such as the sensor level, feature level, score level, and decision level multimodal systems. They emphasize the advantage of the multimodal systems over unimodal and traditional systems in terms of robustness and accuracy, since in multimodal systems there is high robustness and accuracy. Other researchers like that of Chowdhury and his colleagues introduced the attention-based fusion mechanism, where the system dynamically weighs the importance of different biometric modalities. This is based on the environmental factors and the user experience. And when it comes with other researchers like that of Ding and Rose, they extend the work of the attention-based fusion. Actually, the attention mechanism was introduced in 2017. It is start for the natural language processing, and later it's expanded to the computer vision topics. And then this strength of the attention mechanism concept is applied in different areas currently regarding to which is related to the AI areas, which those scientists demonstrate significant improvement in accuracy for multimodal systems by adapting fusion weights based on real-time data inputs. Marcel and his colleagues and Akhtar and his colleagues also focused on liveness detection techniques to counter just spoofing attacks, which is fake attacks, and reinforcing the need for this mechanism to enhance biometric system security. Actually, the generative AI has its own impact on those spoofing attacks, since individuals can generate synthetic and fake fingerprints, iris images, and fake audios based on a trained model, which is based on the actual or reality data sets. So after they generated those synthetic data sets, and so they try to spoof or attack an individual by using those fake data. And active research continues on the challenges of computational complexity, scalability, and generalization, aiming to balance security, usability, and performance in multimodal systems when we try to increase or integrate liveness detection, and when we try to use the multimodal systems, the complexity and scalability and generalization becomes another challenge. When it comes to the methodology section of this research, let's explore what is the methodology behind this system. The process begins with acquiring and pre-processing biometric data, which is the fingerprint and the iris and the voice. We then extract unique features from each modality. And then the attention-based mechanisms determines the importance of each feature. And this information is fused to make the final authentication decision. And we have also conceptualized how to integrate the liveness detection into the system. When we come to the data acquisition and pre-processing, to ensure the accuracy of each modality, we use advanced equipment and techniques. For fingerprint, we use a high resolution, already we'll come up with the data sets. High resolution capacitive sensors are used, and the data is resized, and it is enhanced and normalized. For example, pre-processing steps like resizing, enhancement, and normalization are taken. For the iris dataset, we use already those who collect the dataset, they use near-infrared cameras, which provide robust images, and even in low light conditions, with proposal steps like for the voice data, we use silence removal, framing, and spectral analysis to ensure the clearest signal. When it comes to the feature extraction, we use sophisticated machine learning models to extract features. For example, for the fingerprint, we use a convolutional neural network, which is inspired by the VGNet. It is common now in deep learning here, and it is used to create for a 256-dimensional feature vector. When it comes to the iris data, it is pre-processed using a modified ResNet architecture. For the voice, we use the male frequency substral coefficient, which is MFC extraction with LSTM network, which is part of the RNN in deep learning. Those features vectors are then ready for fusion, which is based on the attention-based multimodal fusion. The core of our system is the attention-based fusion mechanism. The system assigns different weights to each modality based on the attention mechanism. In simple terms, the system dynamically decides how much importance to give to each parametric input. For example, whether high importance given to the fingerprint or the iris or the voice part. This enables more flexible and accurate authentication, particularly in scenarios where one biometric might be less reliable than the others. For example, when the fusion is the total authentication system, the fusion is the sum of those three modalities, which is based on the attention mechanism. From this formula, you can see F1, F2, and F3 are the three vectors which represent the modalities. The coefficients 1 to 3 are the attention widths. So the system dynamically decides how much importance to give to each parametric input. When it comes to the model architecture, as you can see and I've discussed earlier, there are three modalities, which is the fingerprint input, the iris input, and the voice input. And each input passes pre-processing stages using those deep learning areas or focus, like the VGNet-based CNN for fingerprints and the ResNet-50 convolutional layers for the iris input and the LSTM network for voice input. And when after each feature vector is extracted from each input, the attention mechanism is applied on the attention layer in Fusion, and then the final authentication decision is made after this. When we come to the experimental setup, to test our system, we combined data from several biometric databases, which are almost all of them are publicly available data sets. For the fingerprint, we combined from the FVC 2002 and 2004, which is common data set for released for competition. And for the iris, we use the Cassia iris 1000, and for the voice part, we use the library speech data sets. And almost when it comes to the iris, there are almost 10,000 of multimodal samples from 1,000 individuals. For valuation metrics, we use accuracy, precision, recall, and performance score. And we will see the result of each evaluation matrix for the baselines, the state of the art, and the proposed method. For the implementation, we have used the Python and just Windows 11 GPU, which is code enabled. When it comes to the model performance visualization, as you can see from the diagram, there is almost a good way of learning you can see, which is both the training and the validation accuracy have grown in a regular manner with the epoch, while the cross-conclusive values have declined. This all speaks to good generalization, since the convergence of the training and validation curves shows minimum overfitting. When it comes to the confusion matrix, from the diagram, as you have seen, we attach the training confusion matrix and the validation confusion matrix in the training confusion matrix. From the confusion matrix for the training, it is a crystal clear that the classifier has high accuracy in classifying the images with 255 true negatives and just one true positive, which means it had done a great job on the training data matrix. It has 61 true negatives and 3 true positives. This may be considered good generalization to ancient data. The high true negative rate is just, in fact, it is very important for authentication systems, since this reflects low false acceptance rates, and it is very relevant in security applications. When it comes to the result for the performance matrix of the proposed system, we get those results as it is mentioned in the earlier of this presentation. The accuracy is 95.31%, which is 1.3% performance over the existing systems. When it comes to the comparison, when we compare our system with previous state-of-the-art methods, which achieved an accuracy of 94.01% accuracy, our system outperforms them by 1.3%. Actually, this improvement is significant. It showcases strengths of the attention-based fusion, and even though it is not yet implemented, the conceptual liveness detection framework. When it comes to the conclusion, we have developed a novel multimodal attention-based fusion authentication system that significantly enhances security and outperforms existing systems. The integration of liveness detection is a major step forward in preventing spoofing attacks, even though it is not yet implemented. And the dynamic weighting mechanism makes the system highly adaptable to different user scenarios. Actually, this work has strong implications for secure authentication in various high security applications like that of smart devices for our phones, or tablets and PCs, and even modern cars, latest homes, even for every organizations that have entrance like universities, schools, business institutions like banks, governmental institutions like different offices. As a future work, looking ahead, there are several promising avenues for the future research. We plan to implement and evaluate the proposed liveness detection framework, which is not yet implemented due to the lack of data sets. Additionally, improving computational efficiency and expanding the evaluation, even for larger data sets, are important in the next steps. We're also exploring the integration of additional biometric modalities like that of hand and even DNA to make our adaptive learning mechanisms to further enhance the system performance even more than this. Thank you. If there is any question, feel free to reach out to me via this email. And it has been a pleasure presenting at PanAfricon AI 2024, and I look forward to further discussions on this important topic. Thank you.
Thank you, Murad, for now we can go to the questions. Any questions from the audience? You're going to force me to ask questions? Okay, I have two questions for you, Murad. The first one is regarding the dataset that you used. So the idea is to have multimodal biometrics for authentication. And when I saw the dataset that you've used the dataset for fingerprints, the dataset for iris, and the dataset for speech from different datasets. That's not for like for the same person, right? It has to be taken from the same person to have an actual meaning. So my question is like, how do you ascertain the validity of your work because you've used different datasets? Now, the second one is you said you have added a conceptual framework for liveness detection. I did not understand what you mean by that, right? Is it part of the your implementation, or is it just simply a proposal for you, for others to add to your work? Thank you.
Very well, thank you, Doctor. Actually, at first, got two questions on the paper regarding the conceptual integration of the liveness detection into this system. I have said it's just conceptual, it's not yet implemented on this paper. It is I already emphasized as a future of. There is not an organized available data which based on the diagnostic detection. Even it is available only for fingerprints, which is live dates. It is common in data set. But for the iris and the voice part, I can't. So I have passed it on the paper. This is the conceptually just practically of our regarding the different model data sets from different sources, since we belong to a single individual. Still, I mentioned this part. Just the conventional or the deep learning models, which is the CNN part and the RSNet, which is the for the fingerprint and the RSNet for the iris, which is the LSTM for the voice. Just takes a pattern. So the model tries to authenticate the particular individual just based on the pattern. When we come to the real world implementation, it is also a limitation. Since in real world implementation, the fingerprint, the iris, and the voice must be from one individual. So I have mentioned this part also as a limitation in the paper. So in the future work, as it's shown, when we get those three modalities from a single individual, it will be implemented. Thanks.
ሌሎች ጥያቄዎች አሉ? ታገስ።
Okay. Thank you, Murad, for your presentation. Just my question is, you point out in your future recommendation about additional models. So, is that in your work, which model is best? What is your finding? Then, why you recommend additional models? What type of models is that you recommend just to identify what is you select in your work the best, maybe in your analysis or in your accuracy, I don't know, or in your methodology? What type of models that you discussed and defined, and what is another research must be done?
አንዴ ታገስ፣ ሌላ ጥያቄ የመጣ ነው።
Okay, thank you very much, and thank you for the brief presentations. I have a background from the cybersecurity, and I'm also did my master's on cybersecurity. And the title is very good, but it's not a question, it's just an opinion or suggestions. If you know the FIDA or national ID, they have three types of authentication, right? They have a fingerprint, they have a facial recognition. On top of that, they're also trying to add a voice recognition. So to a person, is that or not? So last time there was a meeting, okay? They said they want additional layer of authentication, like the live one, if that person is real or not. Because these days, you can forge someone's voice or fingerprint or his facial recognition. But the problem came here is they want to add additional layer of security with the live, even when he's blinking his eye, is real or not. So maybe from the presentation I found out he's doing this kind of authentications. Maybe, I'm not sure if he's have any contact or any colleague who's working in FIDA or national ID. So his solution maybe can ease their jobs and will bring the need. So my suggestion is maybe he can contact them and maybe he can work them. Thank you.
Wait, let him answer these two and then I will come back to you. Murad?
Okay, thank you. For the first question.
No, no. Okay, if you want to hear for the third one, there is another guy. Okay.
Thank you for giving me a chance. Maybe to recognize the biometric, everybody have a unique biometric, and it won't be digitally generated, but the voice can be digitally generated. How can his model can detect digital voice from the real voice? Thank you.
Murad, you can go answer the questions.
Okay, thank you. For the first question, actually, I have said the chosen models for the fingerprint part. We use the convolutional neural networks, which is part of convolutional neural network, which is a VGG. For the iris, the chosen model was the RiceNet 50, and for the voice part, there we use the LSTM. So the chosen deep learning framework are those. But if we train those models using a real data set, which is from a single individual, which is taking the fingerprints, the iris, and the voice from a single individual, and with enough data set, pure data set, the system will be more robust and efficient. So those are the recommended models in each of the three modalities. When it comes to the second person, actually, I think it's not a question. It is suggestion since he recommends me to contact the FIDA, which is the national aid. I will try. Still now, I didn't contact them. For the third question, he said voice can be generated. Not only voice, even fingerprints can be generated using the GNI, which is the generative AI, which is using maybe VAs, which is a variational autoencoders. Even by using those generative AI models, someone can generate not just, which is even difficult to differentiate which one is the real and which one is fake fingerprint or iris image. So the solution for this is that is why the concept of the liveness detection is come on. In liveness detection, for example, for the iris part, the person will be asked to blink his eyes, for shake his head, even in fingerprint to rotate his fingerprint. There is a sound when, if you have seen the Binance updates, for example, they ask liveness detection to authorize a particular individual. So that is the liveness detection is, even though it is not yet implemented in this paper, the solution for blocking those attacks, which is the fake generated voices, iris images, or fingerprints, is the liveness detection for all the three modalities. But to implement this liveness detection in this paper, getting the three modalities from a single individual, which is enough to train a model, is difficult. It can be done as an individual, maybe for the future by combining with the government organizations like the example of the national aid teams and some other institutes like that of the PanAfricon AI. I hope we will like it. Thanks.
Okay, thank you, Murad. Any other question? Okay, so I think in his paper, like he's not done the liveness detection per se. What he's proposing is like the methodology to implement it. So that would be his next work, I hope, to include the liveness detection in his like in his multimodal biometrics and present it maybe next year, or I don't know, in other venues. So we've come to the conclusion of our session today. So first we looked at web application security by Mulgeta. And then we looked at the integration of explainability in the detection of attacks on a network by Slushy. And then with Murad, we just saw, we looked at multimodal biometrics for authentication of users. And Gadisa gave us a talk on detection of fraud, Simbox fraud on a telecom network. And finally, Duresa gave us a survey on vehicular vehicular networks and like composition on vehicular networks. And so we got insights on many things, different aspects of research. I hope the talks were not, I mean, they were mostly technical, and for many people they could be difficult, but what I can tell you from this session is that you actually saw what research by Ethiopians is done all over the world, because Doresa is did his work in Germany, and Gadisa did his work in Adama, right? And I don't know where Murad is, but Tleshi is not here. He's, I think, in Italy. So what I'm saying is that in many different areas, research are done by Ethiopians, right? So what I want the audience to take from this session is that that there is research being done everywhere. The only problem is that we don't publish it, like we don't publicize it. Like Gadisa was saying earlier, you do some research, you come up with a solution, but it's left on the shelf, right? These are like the venues where you show your work. People give you feedback, and people take the ideas from you, and then they expand on them, right? That's what conferences like this are meant to be. I'm told by the organizers to tell you that this session continues tomorrow. There are 2 papers that we're going to look at, so please.